speed and angular speed. Speed and angular speed. Write on the first point. The velocity or speed, the velocity or speed of the nth orbit, the velocity or speed of the nth orbit is Vn is equals to Ze square by 2n h epsilon naught. So the value of, write down the next point, the value of E square by 2h epsilon naught, the value of E square by 2h epsilon naught is equals to 2.2 into 10 power 6 meter per second. 2.2 into 10 power 6 meter per second. Then Vn will be equals to 2.2 into 10 power 6 into Z by n. Z by n. So V is directly proportional to Z and inversely proportional to n. Write on the next point. E square by 2h epsilon naught, E square by 2h epsilon naught is called as fine structure constant. Fine structure constant. Fine structure constant. Structure constant. Write down the next one. Omega is directly proportional to z square. Next one, omega is inversely proportional to n cube. Omega is directly proportional to z square and inversely proportional to n cube. So what is the relation between angular velocity and the frequency? Omega and f. Relation? 1 by omega is equals to 2 pi f, no? Or I can say t is equals to 2 pi by omega. Yes, no? If I write like this, omega will be equals to 2 pi by t, which is nothing but 1 by t is nothing but the frequency. So f is directly proportional to z cube and inversely proportional to z square and n cube. Directly proportional to z square and inversely proportional to n cube. So since we are talking omega is directly proportional to z square and inversely proportional to n cube, and f is directly proportional to z square and inversely proportional to n cube, what about the time? N cube by z square. Right on the next topic, hydrogen spectrum. Hydrogen spectrum. So open the page number 300. 300, page number 300. So left side top corner, the spectral line is there, no? You can mark that formula. 1 by lambda is equals to R into 1 by n1 square minus 1 by n2 square. Okay. So what are the series are there? Lyman series. So how many are there? Okay. So for the first one, n is equals to start from 2, 3, 4. For second one, okay. So based on this, we will substitute the values and try to remember the series. Okay. For series, try to remember the values also, the value of n. Okay, where it starts. And what are the regions? First two are ultraviolet, visible, and next three are infrared. Okay. Write on the next one. Like you can mark that formulas there. Mark the formula and I'll say the point. The number of lines emitted, the number of lines emitted when electron come back to the ground state, from the excited state. So formula is n into n minus 1 by 2. Write on the note point under this. If I take three series, like let me take this is 1, 2 and 3. So energy excited from third to 1, let me take it as E3. Okay, I can come 3 to 1 directly, or else I can come 3 to 2 first and then 2 to 1. Then energy will be equals to E3 will be equals to E2 plus E1. Take down. Suppose if they are asking in terms of wavelength, it is 1 by lambda 3 will be equals to 1 by lambda 2 plus 1 by lambda 1. So these are the two important formula which is not there, I guess, in the book. So today 303 by T log N naught by N. So 3 formulas are there, so mark that. And off life period and mean life. Okay, so mark these formulas. We'll do questions. I'll do questions on this PYQs. So write the topic semiconductors. So the topic which we are going to see is logic gates. Write down the topics: logic gates, semiconductors, logic gates, semiconductors, PN junction diode. Logic gates, semiconductor, PN junction diode. So under PN junction, we are going to see Zener diode, a rectifier, Zener diode, rectifier, and solar cells. Solar cells. So in rectifier we will see off wave rectifier and full wave rectifier. Okay. Right on the first topic, the difference between analog circuit and digital circuit. Analog circuit and digital circuit. So make a tabular column, analog, digital. Okay. So in analog circuit now we will be talking in terms of waves. Okay. So there will be up and downs in waves. So there will be n number of values we can get it. But in digital circuit we will be talking in terms of 0 and 1. Either it is a true or false, or yes or no. So analog we will talk only in terms of waves. Analog we will talk only in terms of waves or graphs. Digital it is based on binary system. It is based on binary system. So which is 0 and 1. It is based on binary system, 0 and 1. So have you noticed this kind of graphs? Like either it will be 0 or either it will be 1. Okay. So the graph will be looking like either 0 or 1. So 0 can be, we can say it is so. If 0 is low, then 1 will be high, like in the opposite manner. If it is false, this one will be true. Then what else we can say? Any opposite terms? Any opposite terms? This one will be no and this one will be yes. Then up and low. Okay, that's what low and high we have written. No. Slow speed, and we can say it is off and this is on. Okay, this is enough, I guess. You can take down. Okay, we'll do some examples now. Suppose they have given 243 in terms of base 10. Okay, that base 10 is nothing but, write down, the base 10 is nothing but a decimal system in terms of 10, decimal system in terms of 10, decimal system in terms of 10. So decimal system in terms of 10 in the sense, can I write this one as 200 plus 40 plus 3? No, 200 plus 40 plus 3, and I can say that 2 into 10 power 2 plus 4 into 10 power 1 plus 3 into 10 power 0. Correct? 10 power 0, no? What is the value? 1. So this is in terms of decimal system 10. Okay. So if they are asking in terms of decimal system 2, then we can write in terms of binary. Okay. Decimal system 2 in the sense, then we can write everything in terms of binary. Okay. So I will give one more value here, 7654. How can we write in terms of decimal system 10? 7000 plus 600 plus 50 plus 4. So this is 7 into 10 power 3 plus 5 into 10 power 1 plus. Okay, you can take these values and we'll go for the next example. Completed? Okay. Write the topic binary system. Binary system. So for example, they are giving the value 101101 base 2. Okay. So I have taken the decimal of 10 now to implement the same step here. Suppose if it is started with 1, so 1 into 2 power 0, okay, plus 0 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power 3 plus 0 into 2 power 4 plus 1 into 2 power 5. So what will be the value? 2 power 5 is 32, correct? No, plus 0 plus 8 plus 4 plus 0 plus 1. So what will be the value of this one? 32 plus 8, 40, 44, 45. So 45 it is in terms of 10. So which is nothing but 40 into 10, 40 plus 5, which is nothing but 4 into 10 power 1 plus 5 into 10 power 0. Getting the point? So everything will be in terms of either decimal, the decimal point of 10, or else it will be in 2. So if it is in 2, this one will be in binary system. Okay. For example, if I consider the value 36, or let me take 35. How to convert this into the binary system? Then what we should do is take the nearest value of the 2 powers. What will be the nearest value of 2 power here? 30? 2 power 5. The remaining 3. So 3 can be written the nearest of 2 power 1 and remaining is 1. Can I write like that? So 1 will be 2 power 5, no? 10 power 5. It is 1 into 2 power 5. Plus, what is the remaining? Like 2 power 5 I can write, and 2 power 1 I can write, and 2 power 0 I can write. So whatever the values are there, no powers, power 5, power 1 and power 0. For that everything is 1 you can take. For remaining thing everything is 0. 0 into 2 power 4 plus 0 into 2 power 3 plus 0 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0. Any doubt here? I will repeat the sentence. So if any values are given like 35 or whatever value, x value they have given, take the nearest 2 power. So for the nearest 2 power is 35 is 32. Okay. So which is nothing but 2 power 5. Remaining I have 3. So 32 went. So remaining 3 I have. So for 3, what is the nearest 2 power? 1. So 2 power 1 in the sense I will be having remaining 1, which is nothing but 2 power 0. Okay. So I can write 2 power 5, 2 power 1 and 2 power 0. Getting the points? So 1 0 0 0 1 1. This is my value in the binary system. Getting? Take the values. I'll give some more example. Try to do by your own. So any doubt in writing the base of 10? Base of 10. So we can expand in terms of 100, tens and ones. So can we do some more example here? Take the example of 24. Get the value 24. So what is the nearest 2 power? 2 power 4. So remaining is remaining value 8. So 8 can be written as 2 power 3. Is there anything left out? So remaining everything is 0. One I can write is as 2 power 4 and one I can write 2 power 3. Right? No. So the highest value is 2 power 4. That's it. So 2 power 4 into 1 plus 0 into 2 power, it is 1 into 2 power 3 plus 0 into 2 power 2 plus 0 into 2 power 1 plus 0 into 2 power 0. So which is nothing but 1 1 0 0 0. This is my binary system. So whatever the value of 2 powers are there, for that I will keep it as 1, for remaining 2 powers I will keep it as 0. So I will give some more questions. So first example is 49, second example is 97, third example 117. Try to do this one. So 49, what is the nearest one? 2 power 7. Zero 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 one. Okay. So into 2 power 2 plus 0 into 2 power 1 plus 1 into 2 power 0. 1 2 3 correct. 1 1 0 0 0 1 correct. Completed? Done. So any doubt in converting this binary system? The given decimal in terms of 10. Any doubts in converting into binary? Done? Okay. Listen, we will do this example. So 49, 97 and 117. So please try to get the values of 2 powers. Okay, 2 power n. So if I talk about 2 power 0, what is the value? 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5. So 32, 64, 128, 256 and 512. Okay, and it goes on. So again it will be 1024. So it is nothing but 2 power 6, 2 power 7, 2 power 8, 2 power 9 and 2 power 10. So up to 2 power 10, please try to remember the values. Okay, like they won't give that much, but in case I am telling. So if we talk about 49, 49 is near to which number? I should go for the less of 49. Okay, so which is nothing but 2 power 5. So I have 2 power 5. Okay, so out of 49, 32 is when? Remaining is 17. For 17, which is the closest number? 2 power 4. That is okay. 2 power 4 I will write. So remaining is 1. So which is the closest here? Like it is 1 only we have, which is nothing but 2 power 0. So 5 I have, 4 I have and 0 I have, which is nothing but for 5 I will write 1 into 2 power 5. For 4 also it is plus 1 into 2 power 4. 2 power 3 is not there. So for that I will take it as 0. 0 into 2 power 3 plus 0 into 2 power 2 plus 0 into 2 power 1 plus 1 into 2 power 0. So 1, 1, 0, 0, 0, 1. This values I need to write. This is in terms of binary. Okay, any doubt? Got it now? So can you do, whoever not done for the 97 and 117, can you do and tell the answers now? What is the second one? 97? 1, 1, 0, 0, 1. Okay. Any doubt? So everyone got the same answer? What about the third one? 117 base 10? 1, 1, 1, triple 1, 0, 1, 0, 1. Okay, fine. So any doubt in converting now? Can we go for the next one? Okay. Right on the topic logic gates. Done. Right on the first point, the operation which gives a certain input and output. Okay, suppose if I talk, there is a function. Okay, I am giving like n number of input for the function, but the output will be only 1. Okay, output will be only 1. There can be any number of input for the function, but the output will be only 1. Okay, so this is the main thing we need to know in the logic gates. Okay, take the diagram. So this is my input and this is my function and this is my output. So output will be always only 1. So what is the difference between the logic gate and logic circuit? Logic gate and logic circuit. Anyone? Then your IP. Logic gate will have only one thing, but logic circuit will have n number of logic gates. Okay, logic gate means only one, but logic circuit means it will be having n number of logic gates. Okay, that is the difference. Right on. Logic gate consists of only one. Logic gate consists of only one, but logic circuit consists of many logic gates. Many logic gates. Done. Okay. So we will draw certain circuit diagrams. So try to answer those questions. Okay. Listen. So here we have circuit here. Okay. Suppose if I talk about the input and output. Input, output. Okay. So like what are the things we have talked in the digital circuit? Either it is low, high, false, true, on, off. So here we will use that on and off. Okay. Suppose switch is off, which means it is 0. Okay. What will be the output? For example, you can take if bulb is glowing, it is 1. Bulb is not glowing, it is 0. Switch is on, it is 1. Switch is off, it is 0. Switch is off now, so 0. So bulb is glowing, so again 0. Now I will close the switch, which means it is on, which is nothing but 1. What will be the output? 1. Okay. Now we will talk about this case. Switch is off, but what about the bulb? Glowing or not glowing? Think carefully. Think carefully here. Glowing. Now okay. The same thing, input and output I will take. Switch is off, which is nothing but 0, but bulb is glowing. Like the current will be coming like this, no? It will travel, but your switch is, it is open. I mean it is open, no? Which means the current will not go here, and it will travel in this circuit. So which means the bulb will glow. But now I will close the switch. What about the bulb? Glow. It will glow. It will glow. No, it won't glow, because a bulb is nothing but it is a kind of resistor. Okay, bulb is a kind of resistor, and wire is nothing but it will allow the current to flow smoothly. There is no resistor in the wire. Okay, which means wherever the resistance are not there, I will take that path. If resistance is there, I won't take that path. Okay, in this path, no, like initially there was no way to go, so that's why I have chosen this path. But now this path is closed, which means I can travel through this path. Getting the point? So bulb is always act as a resistance. Okay, so if switch is closed, that is 1, output will be 0. Take down. So once you have understood this one, now we'll go for the two switches. ఏమైంది మేడం నిద్రపోతున్నారా ఏంటి? Okay. Okay. Listen here. Listen. So there are two inputs here. So there are two inputs, that is switch 1 and switch 2. Okay. So let me take S1, S2 and the output. S1, S2 and output. Okay. Now current is traveling, but it is open, which means there is no path to travel and give the glow for the bulb. So if S1 is 0 and S2 is 0, what about output? 0. Okay. Now what I will do is I will close either one. Okay, the first one I will close, which means this is 1. Second one I will keep it as 0 only, which means it is open. What about the bulb? Will glow or not glow? Will glow. What about the second case? If I open this one, if I close this one, which means 0 and this is 1, will glow? Okay. If I close together 1 and 1, will it glow? No. Current is coming, splitted, I1, I2, again it will come I1 plus I2, which is nothing but I only. It will glow only, no? Okay, this is the first case. Can you give answer for the second cases by your own? This is S1, S2 output. Okay, first condition I will take the same thing. Okay, two switches, no? 0 0 1 0 0 1 1 1. For the first condition, will it glow? Because current will stop up to this only, it won't travel, which means it won't glow. What about this one? One. ఇది క్లోజ్ చేసిన బట్ ఇది ఓపెన్ లో ఉంది, ఇక్కడ ఎలా ట్రావెల్ అవుతుంది? 0. If I close together, any doubt? Take down. Think logically. Logically. That's why logic gates. Okay, so in this, no, the current can travel either S1 or S2. Yes, no, either S1 or S2, which is nothing but it is OR operation. And this one I need to travel in both S1 and S2, which is nothing but AND operation. OR gate, AND gate, NAND gate, NOR gate, not a gate, not a gate. So understood the conditions, now why it is OR gate and why it is AND gate? Either S1 or S2, and this is S1 and S2. Okay. Okay, done. Boolean algebra. See, listen here, what I told, OR can be taken as positive, that is plus, and can be multiplication, that is dot. So OR and so 0 plus 0 output will be 0, 0 plus 1 output will be 1, 1 plus 0 output will be 1, 1 plus 1 output will be again 1. Okay, so either false, false, both will be false, false, true, both will be, I mean it will be true, and true, false, output will be true. If it is true, true, output will be true. Here it is 0 dot 0 will be 0, 1 dot 0 will be 0, 0 dot 1 will be 0, 1 dot 1 will be 1. Okay. So this not is nothing but it is opposite of the value whatever we are getting, not NOT, not. So if I am getting the value of A, which means output will be A bar. Okay, that is the meaning of not. Like if I get the true value also, it will give us a false. If I get the false value, it will give us true. The opposite of the value what I am getting. That is the meaning of not. Okay, I will write some conditions here, try to analyze. Completed this one? Done. So the first one, 1 bar will be equals to 0, 0 bar will be equals to 1, the NOT gate. Okay. The next one, A plus 1 will be equals to, what is the value we will get? A plus 1. A can be anything, 0 or 1. What is the value output I will get? 1, no? Getting the point? A can be, I will write here, A can be either 0 or 1. So see only the operations. I am using plus here. 0 plus 1 will be 1, 1 plus 1 also will be 1 only. Okay. The next one, A plus 0 will be equals to A plus 0, 0, 1, 0 or 1. It is depends on A, that's it. Fourth one, A of A plus B, A of A plus B. A of A plus B. Alright, take the distribution A dot A plus A dot B. So 0, 0, 0 only will get 0, 1, 0, yeah, 0, 0, I mean 1, 0, 0, 1, 1, 1. So it depends upon the value A plus A dot B. Take down the first 5. Next we will go for the next one.